Hey, it's Mr. E here, and our aim for this video is how can we use the unit circle to find exact values of given angles. So here's a nice little warm-up for you. I want you to solve for x. Okay, so to solve for x, we have to choose from the appropriate trigonometric ratio. So how does that acronym go? It's SOHCAHTOA, right? And you got to pick the appropriate trig ratio based on the information that you have in the diagram. So we have an angle, we have the hypotenuse. Well, actually, we don't have the hypotenuse. We're looking for the hypotenuse. And what we are given is the adjacent side. So now, ask yourself this. Which one of these formulas or which one of these trigonometric ratios relates the angle, the adjacent side, and the hypotenuse? Well, that's the cosine ratio. And if you write the formula down, the formula says the cosine of theta is equal to the adjacent side over the hypotenuse. So let's go ahead and substitute. So it's going to be the cosine of theta, which is the cosine of 30, theta is the angle, is equal to the adjacent side over the hypotenuse. Now all we have to do is just solve for x by doing a little bit of algebra. So we can go ahead and put this over 1. We're going to cross multiply. So we're going to have radical 3 times 1, and then x times the cosine of 30. So we get radical 3 equals x times the cosine of 30. I'm going to keep it as cosine of 30 and not use the decimal formula. That way I can get an exact value. So I'm going to divide by the cosine of 30 here, and I'm going to divide by the cosine of 30 here. This is going to cancel out, and I get radical 3 over the cosine of 30 equals x. So let's take out our calculator and let's figure out what radical 3 over the cosine of 30 is. Okay, so first make sure you're in degree mode because we're working with angle in degrees, so make sure you're in degree mode. And we are now. So you're going to write radical 3, make sure you close that parentheses, over the cosine of 30, and you get 2. Whoops, I got 31 in there, should be 30. You get 2, so x is equal to 2. Okay, so now this is 2. Now let me just point something out very simply. What you're going to notice here is that the ratio of the adjacent side to the hypotenuse is radical 3 over 2, or radical 3 to 2. That's what we mean by a trigonometric ratio. You know, the ratio of the adjacent side to the hypotenuse is radical 3 to 2 when the angle is 30 degrees. And there are other important ones too that you should memorize. We call these the important angles. And these are important values that you should memorize. But for now, I'm just going to ask you to copy them down, and then hopefully by the time we get to the regions, you would have had them memorized. So the one we just saw right now was the cosine of 30, which is radical 3 over 2, because the ratio of the adjacent side to the hypotenuse is radical 3 to 2. Okay, so that's how we get these. Let's move on. Let's talk about the unit circle. So the unit circle has a radius of 1 unit. So here's the radius. It's 1 unit. And its center is at the origin of the coordinate plane. So here's the center. It's at the origin at 0, 0. Now, what's so important about the unit circle? Well, this is what's important about it. Points on the unit circle are related to periodic functions. more specifically to the cosine and the sine of theta. So let me go ahead and just draw an arbitrary theta or an arbitrary angle. And let me explain to you what this point over here that I'm going to call P represents for theta. Okay? All right. So suppose an angle in standard position has a measure of theta. The cosine of theta is the x-coordinate of the point at which the terminal side of the angle intersects the unit circle. So here at point P, the cosine of theta is represented by the x-coordinate, and the sine of theta is represented by the y-coordinate. So that's the important thing about the unit circle that you have to know, okay? Points on the unit circle, they're related to cosine and sine. So the x-coordinate represents cosine and the y-coordinate represents sine. So how do we use this? Let me get rid of that. That should not be there right now. Okay, there it is. Okay, example 1. Find the exact value of the cosine of negative 120 degrees. So I'm going to show you how you could use the unit circle to find this exact value. Our first step is to sketch the angle in standard position. So we're going to go ahead and do that. Let's get rid of that. Let's get rid of that. Let's sketch our unit circle. There's our unit circle. So now what we want to do is we want to sketch our angle in standard position. So we want to sketch negative 120 degrees in standard position. So if it's in standard position, we know that the initial side has to be here. Since it's a negative angle, we know that it's going to open in a clockwise fashion. So about here, more or less. So this angle here is negative 120 degrees. So we have our point P over here. I'm going to call that point P, that intersection there. Okay, the next step is to find the reference angle. So remember, we said in yesterday's lesson that the reference angle is the acute angle formed by the terminal side and the x-axis. So our reference angle is right over here, and it's 60 degrees. Next, find the exact value of the trig ratio for the reference angle. So since we're looking for the cosine of the angle here, I'm going to look for the cosine of 60 degrees. I'm going to have to get the exact value because we want exact values here. So find the exact value of the trig ratio for the reference angle. So let's go back to our table. What's the exact value of the cosine of 60 degrees? So the cosine of 60 degrees is exactly 1/2. So here's what I know so far. I know that the cosine of 60 degrees is 1/2. So let me just go ahead and write that here. Cosine of 60 degrees is equal to exactly 1/2. But as you can see, the angle is over here in the third quadrant. And in the third quadrant, cosine is negative. Why is cosine? So that's our last step. Determine if the trig ratio is positive or negative. Why is cosine negative here? Well, remember we said that cosine is the x-coordinate, cosine of theta, and then sine of theta was the y-coordinate. Well, if you look here, the x-coordinates are negative. So we're going to say that the cosine of negative 120 degrees is negative 1/2. So that's our final answer, negative 1/2 is our answer. And essentially, guys, all we're doing is we're just using the reference angle to find the exact value, because we don't have exact values for 120 degrees, right? If you go back to our chart, we don't have 120 degrees here. You just have exact values for 0, 30, 45, 60, and 90. So what we essentially have to do is just use the reference angle. The reference angle is 60. So what's the exact cosine of 60 degrees? It's 1/2. But since the angle's in the third quadrant, I have to account for that. In the third quadrant, cosine is negative. Let's go over the quadrants real quick, and how cosine and sine relates in the quadrant. So in the first quadrant, cosine is positive and sine is positive. Okay, because the x-coordinate is positive and the y-coordinate is positive. In the second quadrant, cosine is negative because the x-coordinates are negative, and sine is positive because in the second quadrant, the y-coordinates are positive. In quadrant 3, they're both negative. Cosine is negative, sine is negative, right? The x-coordinates are negative and the y-coordinates are also negative. In quadrant 4, cosine is positive because the x-coordinates are positive, and the sine of theta is negative because the y-coordinates are negative. If you're wondering how we get tan, it's very simple. Tan is just cosine over sine. So tan over here is positive over positive, so tan is positive. Tan over here is a negative over a positive, which is a negative. And tan over here is a negative over a negative, which is a positive, so tan is positive here. And then over here you have a positive over a negative, so tan is going to be negative here as well as sine. So just remember this, right? Tan is cosine over sine, and that's how we get tan positive here, tan negative here, tan positive here, and tan negative here. Okay, let's try one more example. Find the exact value of the sine of 150. All right, look, it's very simple. Just sketch the unit circle and sketch the angle. Let's get rid of that, and let's get rid of that. So let's sketch the unit circle. We're gonna sketch the angle in standard position. So the initial side has to be here. Whoops. Let's go ahead and fix that. Oh boy, all over the place. Okay, so there's the initial side. 150 degrees is going to be about here. So from here to here is 150 degrees. What's the reference angle? The reference angle has to be 30 degrees. So then I ask myself, what's the sine of 30 degrees? Go back to your chart. Sine of 30 degrees is what? Sine of 30 degrees is 1/2. But the reference angle is in the second quadrant, so I have to worry about the sine. I have to worry about the sine of sine, if you know what I mean. If it's when I have to worry about whether sine is positive or negative in the second quadrant. As it turns out, sine is indeed positive in the second quadrant. So the sine of 150 is 1/2. Positive. That's my answer. 1/2. Okay, here's a Nice one for you. Try it out. Write your answer on the comment section. Hope this video helps. Take care.